Good evening, everyone. Today we have a workshop on jumpstarting your ideas using AWS Serverless. So we have with us Mr. Dhaval Nagar, who will be taking the workshop. He's a community leader and consultant at AWS, having more than 10 years of experience in the industry. He's 12x AWS certified and is the founder of AppGarment. His high expertise in cloud design and development of complicated cloud-native applications, and will be conducting the workshop on deploying applications in the cloud using services like AWS Serverless. On to you, Dhaval, sir.
Oh, thank you. Thank you, Aryan. Thank you, Shivans, for having me today. Now, first of all, I would like to, thank everyone to invite me. I usually don't say no when someone from the students community invite me, because there's always a kind of a good way to share the knowledge. I passed out. I completed my master's in 2006, so that is close to 15 years. I've been professionally developing the solution. So I'll actually, before I share anything, I'll jump onto the presentation and I will share some of the things from there. I'll turn off my video. Before I start, so I'm at the office. My office is around the main road, so that might be due to the current hours, evening hours. There might be some background noise. Do let me know if there is a persistent noise or anything. Okay, so I'm turning off my video for now. I'm going to share my screen. Let me know if that is visible or not. Okay, so as the topic says, today's session is all about exploring the AWS serverless services and how it helps in kind of jump starting the tech idea. So I have there are a few interesting words: jump starting, to fast track the kind of development and implementation, deployment and stuff like that. And the notion of serverless, which is kind of growing rapidly. It has been 5 years since the space has been started, and now it is the kind of thriving. So about me, I am kind of heavily certified in the cloud technologies. I have 12 AWS certifications, couple of Google Cloud, Docker, Kubernetes certified as well. I run the AWS community in my city, Surat, Gujarat. I own cloud consulting, development and consulting firm AppGarment. We are also AWS consulting partner here in Surat as well. And I'm also an AWS Serverless Hero. This is kind of a designation the AWS gives out to people around the world who are sharing their knowledge around the serverless from one place to another place. I've been talking about serverless, writing about serverless for a very long time. So yeah, it's good to have this kind of a thing. So today's session is all about introductory. I actually put this kind of things before I start the presentation, just to give the overall detail that what exactly that we are going to expect throughout the session. So we'll be exploring what is serverless, why it is required, how it helps, along with the plethora of AWS services that is currently there. Believe me, many of the people doesn't know how many AWS services related to serverless are there, and it is good thing to know those things. Like I mentioned, and that's one of the reasons why when I interact with a student, I always mention them. This is my 15th year professionally designing and developing solution. I started using cloud a few years back. I started extensively using AWS just 5 years back, and yeah, you have plenty of time. If I can do it after 15 years, you have huge amount of time. So yes, that's why I will stick to the introductory. We'll go through the different concepts and we'll see how we do. So we'll stick to the idea phase. So when the title says jump starting your idea, whenever we plan to design an application, okay, this one I'm focusing on to designing a backend specific application. So nowadays, if we split the application into a couple of things, front end and the backend part, where the front end is nothing but your website, your web UI, or your mobile application where your user will interact either from the browser or from the mobile app. And the backend is a place where you run your business logic, where you host your APIs, where you run the databases, save the data, do the calculations, and everything happens on the backend side. So when we talk about cloud, it is all about actually having the backend in place, the backend infrastructure in place where most of the things are running. And then you are using the mobile applications or the front-end applications to interact with the backend. So this one, as an example, we are taking the backend. That's where the cloud and the serverless will help. So when we want to start building an application, our first thing that comes into our mind is what will be the language, programming language that we'll be using. So looking at the current state, Python, Java, JavaScript, Ruby, PHP, a number of programming languages available. Framework, once you decide on your language, then next comes which framework will be good enough to build your application. Now, you can write the whole application using just the language, but it will be kind of a tedious task. If you are not using the framework, you are kind of writing many of the foundational logic on your own. Imagine without the web framework in place, you need to design and build your own web server. Okay, so use the frameworks like Node.js, which is kind of a framework for the JavaScript. You can run JavaScript on the backend, Django, Rails, Laravel. So these are the different frameworks available for the different languages that actually gives you kind of a half-baked solution, and you can start putting in your logic to build your application. Then the type of application, as I mentioned, this is more of a decision that whether we are writing the web application, whether we are writing the mobile application backend, or whether we are writing some headless applications. Now, when we talk about headless applications, the data processing, that also covers the machine learning and artificial intelligence, where it actually crunches the data, it actually processes the data and saves the output somewhere, and then you use another application to actually use that output and show the result. Okay, and where we will run it. Now, after all this decision, when you start writing your first line of code, the usual choice is your own computer. Okay, your personal computer, whether it's a Windows, Mac, Linux, that is the place where you keep all your code, where you run your code, and via the URL, whether it's a local host or some IP address, you actually use that to taste in your browser, or another mean to actually taste it outside. Now, if you want to move it out from your physical computer, your personal computer, then the next choice is where will you host it? In the hosting provider. So you acquire some kind of virtual machine somewhere and you start putting your code. So we'll go through some kind of a semantics of a traditional application. This is, many of you will be able to relate because you have been doing this. I assume you have been doing this in your academics as well. So your physical computer or your virtual machine, virtual box or virtual machine in the cloud, one and the same thing. So you use that and you host your application inside that. Let's say your application is pretty simple. It allows the users to sign up, log in, allows the user to upload some file, delete some file, and stuff like that. Very, very, very basic, simple application. This entire application runs on a physical or virtual machine. These are the building blocks. So you have the physical machine, inside that your program runs in the middle, and you have the database. Most likely, if you're using your physical machine, your database is also hosted on the same machine. If you are using virtual machines, or you are already practicing with the cloud, which is a good thing if you're already practicing, then you create another virtual machine, host the database there, and link the two together. Files are usually stored onto the same machine where your programs are, unless you start using some kind of a file storage service. So when everything runs, you interact with your code via the browser. Okay, everything is working fine. So your application will respond to the request. It will show you the UI. It will run all the logic that you have written, and it will save the data, and it will perform all the tasks as expected. Let's say it starts breaking. Maybe you think that your personal computer is out of the CPU, your code is occupying a lot of CPU or RAM, and you want to free it up to do some other task. So you will stop your service. Now, the moment you stop your service, it will stop responding because the code is not running. Your computer is not running the code that can serve the request. So that is the first bottleneck. If something goes wrong, if you stop your program or your service, whatever web server or whatever that you are referring to, it will stop responding. Okay. Your disk failed for some reason. Your files corrupt for some reason. Your database couldn't start for some reason. In all those instances, it it will basically start failing. Okay? When there are so many, now let's say everything works fine, but you still have a limitation of your kind of a resource. So you have a very finite RAM, maybe 16, maybe 8 GB, 16 GB or 32 GB of RAM in your physical computer or virtual machine. You have the CPU cores 4, 8, 12, 32, but at one point it will have a limitation. So for a small number of users, it is fine. But the moment a lot of people start using your service, it will also face an issue of limited resources. Okay, that will also hamper the overall application. It may go down, it may not respond to many of the users properly, or in time, it may respond with a lot of delay because there are not enough resources to actually fulfill the request. So this is how the traditional services work. Okay, now imagine you have hosted this and everything is fine, but you know that the users of your application are going to consume this particular service only at certain point of time. So let's say if it's university specific application, which usually active around morning to evening time. After the evening, nobody uses, or there are only rare uses. So for the first 8 or 10 hours in the day, you are using that, and after that it is not being used. Now in that case, you still need to make sure that the infrastructure. So when we talk about the infrastructure, we talk about the machines, whether it's a physical or a virtual machine. We talk about the file system, we talk about the database servers, we talk about the program, either the web server or any other code that has to keep running. It has to keep running so that whenever the request comes, whenever someone wants to use the service, your program will receive the request and will process the request. So it's kind of a static infrastructure. It is called a static infrastructure, which is up and running in the anticipation of any request will come eventually and you will start serving it. Okay, so this, although it's not a bad thing, but when you talk about the large infrastructure, it's a bad thing because your resources are idle. You still need to pay to the provider, whether if it's your physical computer, you need to keep it up and running, connected with an internet, give the power continuously. So there are intangible costs. You still need to pay for the energy that your computer is using. If it is hosted into some kind of a hosting provider, then you need to pay for the seconds for which you are keeping it running. So if you are running it 24/7, even though there are no users, there are no requests, you still need to pay to your hosting providers. So that's kind of an overall concept of the static or fixed infrastructure. It can scale up and down depending on the configuration and other things and the modern mechanics of it, but it is still very static infrastructure. You need to keep it running. You need to, it has to be there for any of the future requests to come and solve. Otherwise, your browser will throw an error, your mobile application will throw an error that the server is not reachable. And inside it, the application looks something like this. Now, I'm not talking about the microservice architecture. I'm talking about still the monolithic architecture. There are many ways to kind of illustrate the same things, but we'll go with a traditional application approach. Here, your entire application works as a part of a single process. So you have written a web application related to e-commerce or some kind of social network or something like that. Everything runs as part of a single application. All of the internal services are kind of inside the same application. If something happens to one of the services, let's say cart is not working or cart starts throwing the error, most likely the other services are also impacted. You have a bug which does not allow other services to function properly. Overall, as I mentioned, this is more of a kind of a fixed infrastructure where you need to keep it up and running. You need to make sure that your code is always running. Processes are all running, whether it's one process or multiple process, database, web servers, or anything else. You need to make sure it is always running. Even if we are not doing anything, you still need to pay, like keep the infrastructure up and running. That's one of the advantage or disadvantages of serverless application. And it does not scale to demand by default. So I'll come on to that later on. But as Shivansh actually distributed this event page, if you saw the in the background, there was a kind of a nice image, in which a person was sitting on a rack of servers. So some of the servers were showing fine, and there was one server which was showing not healthy. Okay, that means you have many servers running, okay, out of which many servers are healthy and few servers are not healthy. So they not healthy means they are not running, or they are not running your program properly, or your server or your application is not going to run properly on those machines. So that is the kind of, when it is basically horizontal infrastructure, where you have multitude of servers and on which you are running your applications, and any one of those servers will actually process your request. So scaling has to be kind of managed. You cannot in your simple little application, you cannot expect your application will scale horizontally depending on the demand. That is not something which is supported by the orthodox or traditional application by default. So coming back to the application itself, what are the different functional components of an application? So every application requires some kind of an authentication. That means the user, you need to allow the user to basically sign up, log in, keep their profile, allow them to change, reset the password, forget password, and stuff like that. Make sure that their private informations are protected. So that is also one of the basic, now has becoming the basic blocks of the authentication part. So authentication is one of the very important functional component. Then next comes the compute. This is very generic term. Compute means a place where your code will run, either the virtual machines or containers, Dockers, or we'll later see in the slides the serverless as well. But this is the place where your actual code will run. Okay, so that being very important thing. So it becomes one of the very critical functional component. Third one is a database. You need some kind of a database. I mean, unlike the 10 years back, now there are a lot of database options. You have the relational database, you have the NoSQL database, you have the in-memory databases, you have the ledger databases, you have the time series databases, you have the graph databases, different kind of use cases, and there are different databases available. But you need some kind of database to which your application uses. Most likely it will be either relational or non-relational, or NoSQL or key value pair database, whichever, depending on the use case. So that is also one of the critical component of any application. Now there are very less application which doesn't require any sort of database, but I assume that there are like 99% of the application requires some kind of a database. Very last, storage. Now storage does not used to be the critical component a few years back, but now looking at the growth of the mobile applications, or the kind of modern applications that everyone designs and builds, there are a series of non-data that you need to save, like the images, or the audio files, or the video files. So these are basically something which you cannot store inside the database. You need some kind of a storage mechanism in place where you can host this kind of files, media files, or some kind of data files, which cannot be fit inside the database really well. Even if you fit inside the database, it is not going to be very recommended or a very performant solution. So storage has also become one of the kind of a critical functional component of an application. Along with those, there are some inherent blocks of the applications. You need your application to be secure, highly available. Servers go down. Then also there are ways through which your application can come back up on another way. If there are any issues with your application, it can it cannot fix itself, but there are ways through which the rest of the application will still work fine. If there are the portion of the application is not working properly, then also the other piece of your application works fine. Performance, obviously, fault tolerant. Again, if some portion of your application breaks, that should not impact the other portion of your application. And we have seen it. You might have seen this into many of the popular applications out there. If certain portion, let's say the billing part, nowadays the big billion days are going on. So Amazon has some sales going on, Flipkart has some sales going on, and like many other e-commerce services has sales going on. Sometimes their payment gateway is not working. Sometimes their cart is having some kind of issues. That does not allow, that does not actually hamper the other users to go through or use the other part of the application. So while they are fixing the portion which is not working properly, the other piece of the application works just fine. So that's that. Auto scaling, obviously we are talking about the very large scale applications. So as the demand grows, so is your infrastructure capacity to actually process those requests. So that is something where is only possible when you have the scaling as part of your application. Otherwise, your application will be limited to the infrastructure on which you have originally hosted. So if you're hosting it on your physical computer, it can take up to a certain request, not beyond that. After that, either the request will stop being processed, or it will process with a lot of delay, because your physical computer has limitation in the resources. So auto scaling is now considered to be the second nature of any of the modern application, whether it's a mobile application that you are building which interacts with the backend, or it's a web application that also interacts with some kind of a backend. And cost efficient. At the end, nobody wants to pay a very large bill by just using these services. So there are, as the number of options are also growing, at the same time, the practices are also growing, that how teams or how the companies can write the efficient solutions, which is also budget friendly, or at max you are paying for what you use. You are not overpaying anything. So drill it down, authentications, as I mentioned, user login, authorization as well, which actually restrict that who can do what. So your normal users can do certain things, your admin users can do certain things. If you have that kind of application which actually allows the user to have some kind of a role, then you, based on the role, you can do certain things and not do certain things. So these all things are part of the authentication or authorization as a component. Compute, you have the APIs which runs, you have the background jobs which is running silently without any invocation. Databases, relational, NoSQL, storage, application files, user files or user data. Now, same thing, let's look at the how, if I need to do something right now, how will I structure it? So the concept of SaaS, which is not new, it's not that old, but it is not that new as well. So nowadays you see a lot of services, they provide the feature as a services. So a very popular example I'll say is the Firestore, okay, or Firebase, which is the entire backend as an application. If you are using, if you have used any of the other cloud-based services, so S3, which is a simple storage service, is one of the very popular AWS cloud storage service, which allows you to actually use or integrate the Dropbox-like functionality into your application. Or Dropbox, which is a commercial storage as a service. So anyone can sign up for the Dropbox and start using that to save their files, data, and everything. So these are there are a lot of services available for different use cases, and the application that we build now that consumes a lot of these services and then combine those together and deliver a kind of a joint solution. So authentication is using some kind of a auth service, auth as a service, web UI. So you, instead of hosting the JavaScript or a single page application, you host it somewhere from where you can load those assets, HTML, CSS, JavaScript very easily. Now, when it comes to the mobile app, you know that you can actually host your mobile application into the Play Store or App Store. So they are nothing. They are not doing anything, but they are hosting your application, and people can go to the Play Store or App Store, find your application, download it, and start using it. You do not need to maintain any infrastructure for that. The infrastructure is maintained by the Google and Apple stores for that. But you still need to make sure that your assets, so your application, Android or iOS, is uploaded there for the people to find. Storage services, so hosting, saving the files in a secure, performant way, and then loading it as and when required. APIs, as we saw, the compute options, and the database is again available as a service. Firestore, Firebase is an example of that. The entire whole database available in the cloud, which people, Android developer will be familiar with that, so they can start using that full backend without actually creating any of the servers or anything. They can just start using those things. So this is one of the another example where I put the different service name as well. So Auth0 is a very popular kind of authentication and authorization service. You can use that just to integrate the authentication inside your application. It comes with an API, it comes with a UI, comes with widgets as well. So it's kind of a drop-in authentication mechanism. And you have wide variety of options. You can host, you can configure it based on the username, password. You can configure it based on the Google sign-in, Facebook sign-in, Amazon, Apple, variety of ways you can configure. So that entire service is doing only one thing. It manages the authentication on your behalf. Okay. Likewise, there are many other services like Firebase, as I mentioned, the whole database in the cloud. Stripe, which manages just the payment processing. Okay. If you are in the India, you can actually use the Razorpay, which is an Indian equivalent to the Stripe. So that way, you do not need to go into the mechanics of how the payment works, how will you write, compliance, storage, and everything. Those all things are managed by the company. So these are purpose-built services. Now, how these are related to the serverless, that we'll see in the next few slides. But as you can see, there are now number of services available for every single use case. And if I need to build an application, I use these services, I combine them together and build a solution. Excuse me. So with that, what I'm doing is I'm actually passing on the entire responsibility down to the service itself. So when someone wants to authenticate, okay, the entire authentication thing, including the validity of the password, whether the password is strong enough or not, saving the user information along with the password in the very sensitive encrypted format, entire responsibility is pushed down to Auth0. Okay, I don't need to write, I don't need to worry about whether will I use the MySQL, whether I use the Postgres, whether I use the MongoDB or any other database to store those things. That is not my responsibility. Okay, so I'm pushing those responsibility down to a particular dedicated service. Same for the other services. S3 is used to actually manage the file uploads, downloads, storage, security, and all those things. So with that, I'm also dividing my entire application into separate services. So each one is managed by a particular microservice. So instead of one application which is doing everything inside that, now my endpoints or now my functional modules is dependent on different services, and I can manage those services differently. They can use the different databases as well, which many of the popular applications do that. They don't use one database for the entire applications. They use different databases for different services. So they can use one kind of database for one service. They can use another kind of database for another service. So now if I circle back the transition of the entire movement, when we started with a physical computer where you keep everything, then you move all those things to some kind of a virtual machine, because you do not want to keep everything onto the physical machine. Your machine can be damaged. It may not be accessible by anyone outside. You need the IP address of your machine keeps on changing, so there is no consistent way to reach to your machine, stuff like that. So you transfer that to a virtual machine in the cloud. At the same time, you're transferring the expenses. Now, if you are using the cloud resources, you pay at the end. When you are using the physical machine, you have to pay upfront. You need to buy those machines, okay, then attach the power, networking, and then start consuming it. When you use those things in the cloud, those are called the rented resources. You first use them, and at the end of the month, you need to pay for what you have consumed. Then the concept of co-locations and the cloud providers came into the picture. Co-locations were it's nothing but it allows you, if you already have a lot of kind of devices or computers, and you do not want to kind of throw them away or sell them, you can actually reach out to these kind of data centers who take those machines from you, and they power it up in their own premise. And at the same time, you are actually pushing the responsibility down to colo provider. So they will manage the infrastructure, they'll manage the physical premise, they'll manage the power, networking, and everything else. And at the end of the month, they'll just give you the bill that this is what you have consumed in terms of power and networking, and you need to pay me for that and few other things. That is also a very, very popular concept a few years back. Then came the cloud. Now cloud gives every sort of functionality and not just hosting functionality. We'll come into that. And eventually, because you want to kind of every passing day or every sometime you want to reduce your overall overhead, you start looking for a newer solution. So containers are one form in which you package your applications and you can move around the container from one place to another place. Now you are not even dependent on certain operating systems or certain kind of infrastructure. You can shift them from one place to another place. And then the final thing came onto the serverless, which is nothing but you are just giving the code, and everything else, every single thing other than the code is managed by the cloud provider. You are not even telling that whether you want the Linux as an operating system or Windows as an operating system. You are not telling that whether the 4 CPU core will be good enough, or you need 8 core CPU, or whether you need 4 GB of RAM or 16 GB of RAM. You are not telling anything. You're just providing your code and let everything else managed by the cloud provider. So eventually, from a lot of expense to least expense, that is one thing that we have received as an advantage. At the same time, now because we are only paying for what we consume, so overall the package software has become smaller and smaller because we are pushing down the responsibility to different services. Our cost is also kind of reduced and only based on the usage. Now the Firebase, if you use the Firebase, you pay for what you consume. Other than that, you do not need to pay anything. You can create the resources and everything, but you do not need to continuously pay. If you're not, the project goes, nobody uses your application, you do not need to pay anything. So cloud provider, first is focus onto the business logic. We are only focusing on delivering the solution, and cloud provider manages rest of the things, whether it's authentication, storage, compute, database, everything else. Okay. And at last, because cost plays a very bigger important role, we pay for what we consume. Instead of in the earlier slide where we saw that if we keep everything running 24/7, we need to pay for that. Instead of that, now we pay only when we consume the resources, not otherwise. This is the, we'll still go into the other part, but I just wanted to give you an overview. If you are want to go explore why this entire momentum started, then this is a very popular paper from the Berkeley. They released a similar paper around cloud computing back in 2009. So exactly after 10 years, they released somewhat similar paper, the growth, prospect, and the future of serverless computing. They released in last year, February 2019. It's very well written. Explains a lot of fundamentals and the future of the serverless computing. So I highly recommend to go through that. So jump starting the application, as we saw that our application is mainly having a lot of components. We want the authentications, we want a place to store the data, we want a place to run our code, and we want a place to store the non kind of record data. We want to store the binary data as well. So instead of building all those things at hand, we need to focus onto the services which actually does those kind of things for us. So write less code. If you are writing less code, that means you are spending more time onto the business logic, and many of those services are already there. So it is very easy to integrate and start your application much faster. Don't reinvent the wheel. Use the service which is readily available. Use the right service for right use case. There are many overlapping services, so you need to understand which service is better suited for what, and choose accordingly. Less time spent on building the same repetitive task. The simple example is the authentication or a file upload. Where and how you will upload, where you will save it. Someone uploaded the file and it is there after few weeks or few months. So how do you make sure that you remove those files because they are occupying the space, but they are useless now? Offload the heavy lifting to purpose-built services. Again, similar example, storage service manages everything related to storage. Authentication services manages everything related to authentication. You do not need to worry about how those things work internally. Now we will be transitioning to explore the AWS services, which service relates to what and how we can use them. So compute is a place where you will host and run your code. So the popular options are EC2, that is a virtual machine, but because we are going via the serverless option, I'll not use the EC2 or virtual machine option. So Lambda at Edge, and the Fargate is serverless offering. Here you can package your code, upload your code, and they will run the code on behalf of you. Storage, we have the S3, which is an object storage. You can actually store 5 gig to 5 terabyte of file, and it will manage it just fine. It's a dedicated service. You do not need to write any code to upload or download the files or anything with that. There are many popular applications use this. Amazon.com, Amazon.in, even the Airbnb uses the S3 to store all of the pictures of the entire thing that they have, the full catalog of the properties they have. So it's one of the oldest service and very popular one. In database, AWS has a lot of databases, but we'll stick to the one which are serverless. So DynamoDB, which is a NoSQL database, highly performant. Snapchat uses DynamoDB for the Snap stories. I don't use Snapchat, but I think I have used the right word, so Snap stories. So they use this DynamoDB, so it is an internet scale database. You do not need to create any instance. You do not need to install any software. You just start creating the tables, and everything else is managed by the DynamoDB as a service. So that is the example of a purpose-built, fully managed service. It is already there. You just need to create it and start consuming it. If you consume it, you will have to pay for it. If you are not consuming it, it is sitting idle, and you are practically not paying anything. You still pay for the storage and other things if you have consumed that much of a storage, but you are not paying for the idleness. Proxy is nothing but how the service will reach out to your compute part. So if you have written a web application, you know that PHP, how the PHP works. Node.js requires the Express to build the web server. Python uses a Django. Laravel is another kind of a web server for PHP. So these are the front end. They take the request and they actually transfer the request to your code, and your code processes it and returns the response back, which will go over the either via the JSON or via the HTML calls. So proxy allows you to take in the kind of request and dispatch the request to the compute layer. At the same time, it manages the scale, security, and other things as well. So if there are 10,000 requests you receive every second, it will manage that as well. So that's why there are, if in a virtual machine environment, you put a load balancer, which is also doing the similar things. It takes in a lot of requests and then distributes the request to different your code. In case of serverless, we have a proxy which takes in the request and dispatches the request to your code. So this middle layer helps to kind of process a lot of requests at the same time, and also provides a scalable, secure infrastructure. So in case of AWS, we have API gateway. We'll see that in a short demo as well. Integration services. So when you divide your entire application into small chunks, how these services, the login service or the card service or the payment service or some kind of other service, how they communicate between each other. So there you can use the queuing system or a PubSub, publish subscribe, that kind of thing, so that you can communicate between your components inside if they are running somewhere else. So in a distributed environment, chances are one part of your application is running on one machine, another part of your application runs on another machine. In case of servers as well, the servers are not going anywhere. Servers are there. It's just that they are not visible. So you as a developer, you as a operations guy, or you as a maintainer of the entire application, you do not need to worry about the servers itself. You just need to worry about the code and the overall other parts of your application, and not about the servers. Then we have few more services which also falls into the serverless category, but those are slightly advanced. So if you want to send out a lot of emails, SMS, push notification, then you use the Pinpoint. You use the SES, that is simple email service, to send out emails. You use the SNS, that is simple notification service, to send out SMS push notifications. Analytics, also if you are building some sort of IoT where you have a lot of devices or they are sending in the data very frequently, then you use the Kinesis to ingest very rapid velocity data. That is also serverless. You do not need to create or set up any kind of a server infrastructure. You can just create the Kinesis pipes and you can start ingesting the data. Athena is kind of in a very simple, it's a very like important service. If you want to, let's say you have a lot of data and those data are part of CSV files. You have gathered a lot of CSV files having the data and you want to query the data. Now you know that your data is structured in a CSV format properly, but to run the query, when we say query, the first thing that comes into our mind is SQL queries. So that means you need to load the CSV into some kind of a database, relational database, maybe MySQL, and then you can actually fire the query and get the result. Now, for a very small kind of a task, you will not load this all CSV, create the database, create the table, load it there, and then run the SQL and then check the result. So this service is actually built so that you can use this kind of a file format, which is a structured file format, and run the SQL query directly against that without doing the ETL process. So ETL is a word which will come to you if you move into your professional career, doing some kind of data processing and analytics and all those things. So it's basically extract, transform, and load. So you do not need to extract any data from CSV, transform, and load into the database to run the query. Wherever they are stored, so in this case, the Athena allows you to run the SQL queries if your files are stored inside the S3. So it becomes, your storage service becomes a database service as well. So that's also a very important service if you want to leverage or query the data without loading those data into the databases. So these are all serverless services inside the AWS space. This again broad set of services under different categories. So in the compute, you have this, you have the storage database, again different services which belongs to the serverless category. Networking, logging, security wise, integration and messaging. Bots wise, I put an example of a demo of a bot as well, how you can build the serverless bot later on. And the other services like the machine learning, AppSync, which is a GraphQL service, and a Pinpoint, which is a communication service. So before we move forward, when we say serverless, there are no servers, visible servers to manage, but there is still a cost attached to many of the resources, and cost is an important part. So every cloud provider gives some way to kind of manage the cost. AWS also has done a very good job. You can actually put all the alerts and your budget. Every application has some kind of budget. So you can actually configure all those things here and then let the cloud provider manage the usage. Let the cloud provider manage the usage of the cost, usage of your cloud resources from here. So you can go inside the AWS environment, go to the budget and billing service, and you can configure it, your budgets. So this is something, if you are everyone who asks me that if they are new to the cloud, AWS as a cloud, this is what I suggest them to do first, so that you accidentally do not incur any unwanted cost. If your capacity is to spend $20, $50, then you just set it accordingly. When you reach to a certain threshold, it will start sending out the alerts, so that you know that you have been consuming the resources one or another way, and you will eventually reach to the target that you have mentioned. Second is some of the serverless services also cost based on the usage. So as I mentioned, pay for what you use. So if the users are making request, that means request is coming to the services, and the service is basically fulfilling the request. So these services charge based on the number of requests and based on the amount of data that has been transferred, along with a few other things. So the API gateway, which works as a proxy, it costs $3.5 for 1 million requests. So it's just kind of an overview that when you start using the cloud services, keep in mind that what exactly is that billing meter, how they actually calculate the cost, whether it is cost based on the request, whether it's cost based on the duration. So Lambda, which is a compute service, there it actually charges you based on how much time you run your code. There is no other way to actually do the billing calculations, because this is a compute service. Your code is going to run, so they are going to measure that for how long your code ran, and based on that you will be charged. So if your code ran for 1 second, you will have to pay for 1 second. If your code ran for 10 minutes, you have to pay for 10 minutes. And if your code only ran for 1 hour in a given month and didn't do anything besides that, you will just have to pay for 1 hour and not the other time throughout the month. Likewise, DynamoDB as well. How many requests that you made, how many data that you stored, and stuff like that. And the free tier has a lot of free limits, so you can actually utilize this to start using this kind of services into your application. Now we'll go through some of the key services before we jump onto the demo. So the first one is S3, which is a simple storage service. This is something that you can actually start using almost immediately. You do not need even a programming experience. This is like a Dropbox for developers. You can actually go inside the AWS, go to the S3, create the buckets. Bucket is nothing but a kind of high level, very unique folder of yours. And inside that, you can start creating the folders, uploading the files, and keep it there. Now, it is not a file storage. It is a different kind of a storage. It is called the object storage, which stores everything related to file. But internally, engineering wise, it is not a file system. It is slightly different. No provisioning required. This was the first major service from AWS back in 2006. You do not need to tell AWS that how many files you will store, or whether you in the Dropbox or many of the other storage services, you need to actually purchase the plan, that whether you want to store 5 GB or whether you want to store the 50 GB or so. Here, you do not need to tell any of that. You just create the buckets. If you have 10 MB of file, you can store it there. Suddenly, you want to store 1 GB, you can store it there. You want to store 100 GB, you can store it there. And depending on how much space that you are occupying inside the S3 buckets, it will actually charge you towards the end of the month, that you have stored 100 GB of file or data. This is what you need to pay. Now you delete that. Out of that, you delete 50 GB. Then next month, it will say that in this month, we found only 50 GB of data stored inside S3. So you have to only pay for the 50 GB. So that is kind of pay for usage. And this was a very innovative idea back in 2006 when AWS launched this. So a lot of companies started using this. And that's when the Amazon or AWS realized that there is a big power in releasing this kind of a managed pay for what you use services. Since then, there are like almost 200 services now that AWS has. S3, I'll give you a very simple example. We have, if you build a service which actually allows the users to upload the files, that's a social media. You are building a social media service. User uploads this images or videos, and people can see it. Now you uploaded it something on Monday, and people saw all those things on Monday, Tuesday, Wednesday, Thursday, and then you are uploading new images. After 1 month, what is the likelihood that someone wants to see the image that you uploaded 1 month back? Very less. So in a trending kind of a nature, as the time passes, the previous resources become obsolete by time. So the frequency at which the people will consume those things, or people would like to see those things, reduces, unless something went viral or stuff like that. So over the period of time, the accessibility of the same file, whether it's an image, whether it's a video or audio, reduces. So that is where either you can programmatically shift that I don't want to keep this file into my storage now because it is occupying the space, and I can use that space to the newer data, and I want to keep it somewhere else. Either you want to delete it or you want to archive it to some other place. Now that, if you need to manage that, you need to write a code for that, which actually checks something every day or every week, once in every week, and transition the file from one place to another place, or even for the backup. Now, if you use the storage services, many of the storage services has the intelligent tiering built inside. So that is nothing but a lifecycle events. You can actually put these small rules that after 7 days, move this to infrequent access. After 30 days, move this to kind of a cold storage. After 1 year or 6 months, just delete the file because it is not required. Now, in this kind of things, there is no responsibility of the application itself. You have pushed down the responsibility to completely on the storage provider. You do not need to write a single line of code. It is just managed by its own. So this is a very kind of a S3 has a lot of features, and these are some of the very popular features. Again, it's highly durable. So once you save it, the chances of losing the file is 1 in a million year, because it has 11.9 of durability. It's a theoretical durability. You can still lose your files, but not very frequently. It's a very rare incident that you might lose some of your data which you have uploaded, because when you upload it first time, it automatically saves it at multiple locations. So the chances of losing that file from all those locations are pretty rare, considering the current state of the AWS as a cloud provider. Highly secure if you configure it right. Security is always subjective. The service can provide you a lot of things, but if you cannot configure it right, there are ways that others will take advantage and access your data. So the security is a subjective thing. By default, it provides a lot of measurements to which you can make your entire storage very secure. And it supports the web hosting as well. This is the part a lot of people are not familiar with. You are writing your React, Angular, or Vue.js based applications. They try to store it or use the application from the EC2 or some kind of a virtual machine. If you are writing this kind of a single page front end application, S3 allows you to actually convert your bucket into a web server, and it is highly scalable. You do not need to create anything. You do not need to assign anything. You just need to load your HTML, CSS, JavaScript from there. It gives you a URL. You can start using your page directly from there. We'll see that as well in few minutes. Next is a Cognito. As I mentioned, I gave an example of authentication as a service. We used Auth0, which is a commercial service, and Cognito is something which Amazon AWS also has. So it's an authentication as a service. You can integrate with Cognito. You can actually, in just a couple of hours, you can integrate the full sign up, login, Google sign in, Facebook sign in, all other things, including the password reset. In your application, whether it's a web application or a mobile application. So this is very powerful service. And the most important thing is, for first 50,000 users, it's free. So you are practically not paying anything if your user base is less than 50,000. Even after that, it charges you based on the active user per month. So if you have, let's say you have 5 lakh users, but at any point of time, only 50,000 or 100,000 users, that is 1 lakh users, come and visit your site once in a month. Okay. So if 1 lakh users uses your site, which uses the Cognito in a given month, first 50,000 is free. So you need to only pay for the next 50,000. Overall, your application has 5 lakh users, but you are only paying for what you are consuming out of the Cognito. So they actually charge based on the number of API calls that you make. So sign in is one API call, password reset is one API call, sign up is another API call. So they actually calculate the unique API calls per user, and then they give you that in this month, we found that this many unique active users your application had, and you have to pay for these many users if they exceed 50,000. So it has all the options. I'll show you. We have an open source application as well, which actually uses the Cognito really well. So it allows you to create this entire user directory, user profiles, a lot of the profile information that you can keep inside this service as well. So you do not need to save the users kind of a country, address, the other personal information in your database. You can simply use this service to host all of those data in a very secure, in a performant way. The next and a very important is Lambda. This is the service which is at the center of the entire serverless movement, because serverless computing means a place where you will run your code in a serverless fashion. There are no servers. So Lambda is a packaged or a fully managed compute service. you write your code. I'll show you in few minutes how we write the code. We just need to package our code and give it to the AWS Lambda, and Lambda will execute the code when the request comes. So it's an event-driven architecture in which it waits for some event. So HTTP request is nothing but an event. Message in the queue is nothing but an event. Likewise, there are number of events. So as soon as it senses an event on which we have put a trigger, it will download our code from their internal repository and execute the code. Now you can actually use many of the languages like the JavaScript, Python, Go, Ruby, PHP, custom runtime as well. And you can write the Lambda functions and you can deploy it. So when the event comes, it will execute the Lambda functions. It will execute it automatically. Internally, it actually creates a micro virtual machines, a micro VM, downloads your code inside that, processes that, and then when it is not required, it will actually automatically destroy the micro VM. So there are servers, but it manages everything internally. That's why it is called serverless. But it doesn't mean there are no servers. It scales automatically. Imagine there are no servers visible. So even if you want to scale, there is no mean to scale it. So this is natively something which the AWS and the Lambda does it for you. If you have one request in a single second, it will process it fine. If you have 100 requests in a single second, it will still process it. If you have 10,000 requests in a second, it will still process it. You still need to configure the concurrency and other things, but you do not need to do anything in terms of infrastructure or code to actually manage this many amount of requests. That's where the scale comes natively to the serverless, because there are no servers. There is no way that you can configure these kind of things where there is full abstraction. Servers are not visible to you. So this becomes the responsibility of the cloud provider. At the same time, this also serves the purpose of a secure environment, because there are no servers. So you cannot log in, you cannot SSH, you cannot remote desktop inside that. Fault tolerant. If something happens to the machine, it will automatically run it somewhere else. Again, because there is no visible machines out there, it will manage those things internally. So fault tolerance, security, scaling, all those things are natively part of the serverless computing. And the Lambda in AWS manages all those things on behalf of you. We do not need to do anything. As we are not doing any of these things, it actually induces the very least operational load. All we need to focus on is the code that we are writing and the package that we are uploading. Other than that, everything else is managed by AWS Lambda service. Pay only for what we consume. So Lambda has a very different calculation meter. It actually, when a request comes, it downloads the code, packaged code that we upload. It will run that, and it will count that how many microseconds that our code has run. So it actually goes into the block of 100 milliseconds. If your code has took, let's say, 1 second, so you only have to pay for 1 second. If your code took 1.1 second, then you need to pay for 1 full second in the next 100 millisecond block. So it is in the iteration of 100 millisecond of a block. So you need to, that is a granular level on which it actually charges. So in a normal server-based environment, you are keeping your virtual machines, Linux-based, CentOS or Windows-based up and running, and you pay for the full server's runtime, even though you are not using anything. In here, it is granular to 100 millisecond block. Next, because there are no servers, you write this. How do you know whether your application has worked properly or not? So there are logs. You always want to see the log that your application has generated. So CloudWatch is a centralized and an integrated service. By default, whatever that you write, all the console log or the outstream logs that your code writes, everything you can find from the CloudWatch. It gives you many of the other metrics, like how many invocations were there for a given function. So you can see that how many requests has been served. Concurrent, how many at a single time, how many requests you received and processed. Success versus failures. There are no like 100% successful code, right? Every code fails one or another way. So you can easily track that how many functions failed, which in a if you are not doing anything, it's very, very difficult to know which part of your application failed. You need to go inside, you need to check the logs, you need to check the errors, and then you can see it. Here, because everything is managed by the Lambda itself, you can start seeing if the Lambda fails. This is the graph for that. So if you X-ray is another service which is meant for the serverless observability. If you integrate with that, integration is also very simple. If you integrate it with that, it actually creates this kind of a graph where each point represents one function. So if it is fully working, it shows green. If it is not working, it shows red, orange for some kind of an implemented performance issues. So this way you can check the overall performance of your applications from the code point of view. If some part of your application is not working, you can see it directly from here. This is a detailed one, because now you are not paying for the full second even. You still want to know that how much time your code took. So if your code is interacting with the database, you want to see that how much time it took to actually reach out to the database, come back, and then you serve the data back to the user. So when we receive a request, we do some processing in our code, then we reach out to the database. The database query returns the data. We again process something, and we return the data back in a JSON or any other format that we want to send back. So all those things you can see here in a breakdown structure. So this gives that where exactly we spend what time. So for the authentication, we spend this much amount of time, overall 297 milliseconds. Then fetch product, so that is the database interactions, took 461 milliseconds. So all those kind of detailing also is now very easily doable. Unlike in a traditional environment, we need to inject the different tools and services to get this kind of a graph. And this is the byproduct of going serverless. Because we do not have the full visibility, that means the server, the serverless service, the Lambda or the AWS has to provide this so that we can assess the different things that is happening inside our application. API gateway, fully managed scalable proxy. It supports 3 REST, HTTP, and WebSocket. So whatever kind of application that you are building, it will work just fine for that. The REST and HTTP is the cheaper option. REST is $3.5 a million requests, and HTTP is just $1 for a 1 million request that receives. And there are various integrations. So it creates a URL. We'll see that as well. We'll go a bit fast. So we'll see that as well, what exactly it creates. It creates a URL, and you can attach the Lambda functions towards the end of the URL. So when you make a request from your browser to a URL, it can dispatch that request to a Lambda functions. Lambda function will process and respond it back. DynamoDB is like extremely popular, fully serverless NoSQL database in the cloud. It looks, if you ever get a chance, if you go inside the console, it looks really simple. All you have to do is just create the tables, but it's pretty massive. Most of the Amazon.com applications are using the DynamoDB. As I told you, the Snapchat also uses DynamoDB for one of their popular features, stories. So there are many use cases of DynamoDB, and at the same time, the single reason why I suggest DynamoDB to everyone is fully serverless. You do not need to worry about anything. If you store the data, you have to pay for the storage cost. If you are making the queries, you only pay for the queries cost. Other than that, you do not need to worry about anything. So this is very popular, and it works with it has a very simple API, and almost in any application you can start integrate and use it immediately. No connection pooling, no need to maintain the partitioning, no need to maintain that whether I need to download some fancy software, configure it, manage the dependencies. Some databases require the minimum configurations like 4 GB of RAM or the 2 or 4 CPUs. All those things are not here because there is no need to assign the RAM, CPU, or anything. You just need to create the table and start using those things. But this is that was a NoSQL database. So let's say you want to still use the MySQL or Postgres, but in a serverless way. So AWS very recently offered the full relational database as a serverless as well. let's say you are doing some kind of a in an academics, you have this quarterly assignment results or your exam results, and you want to build a service which actually shows the result from a website or a mobile application, but it runs on a certain time. Other than that, it is not running. But you want to keep it very simple, so you want to still use the MySQL database so that you can taste everything locally, and then you can move to the cloud and then use the cloud service. So Aurora Serverless is a fully relational, fully managed, and a fully serverless database. It actually, when the query hits, it will start the server. So there is some time. So when it will start responding, it may take few seconds or few minutes to start it up. And you can configure that if there is no request for, let's say, 15 minutes or half an hour, it will automatically shut it down. When the next request comes, again it will start. So it is not as such a fully serverless, but it is packaged in a way that it can be used in a serverless. Again, the startup time is high, so you cannot use it for a frequently accessed application. But you can, if your application's nature is an infrequent access, example I gave, that you want to build an application which only shows the exam scores, so which runs only sometime in a day or only for a few days, you can actually use this kind of service, which will work. After that event is passed, you are not using it, so the database will always stay down. Again, you do not need to, if you use the RDS proxy and other things, you do not need to manage the connection pooling. You can use this directly from your Lambda functions very, very easily. Now, the interesting thing, let's see if most of you are with me. So we'll go to a simple demo. Okay. So I'm going to, first of all, I'm going to use this. If you are not familiar, I highly recommend to check out this serverless.com. It has the premium, it has the open source version as well. It's very popular, used by like huge number of developers and companies. You can see the very good number of GitHub stars as well, almost 15.7 million downloads. So we'll use this framework to build a very simple application, and this is my cloud environment. So I have logged into AWS. I have 0 functions. Uses the cloud formation, which is the code, your environment. Instead of going inside the AWS and clicking and creating everything, which is clicking and then creating the resources, it actually, you can write the code to create the resources in the cloud environment. So it internally uses the cloud formation. So let's do one thing. Let's create a demo application. So this is the command. So let's create template. I'm using the AWS and Node.js, and I have created a demo application called Desert Hack Demo 2. So see, I have So by default, it creates a simple JavaScript file, which is my simple Lambda function, and it creates a YAML file. YAML is similar to JSON, but without the braces and other things. So it's kind of a trimmed down version of JSON format. So it is a structured way to define the data. So by default, when you create a new project using the serverless framework, it actually creates one function, and it creates a configuration file to deploy this one function into the cloud environment. So I'm going to just set up few things. I'm using this is a Node.js based. So any of you are familiar, I'm using the NVM. I have multiple versions of Node.js. I'll create a bit larger so that it is visible. And I have Node 12.14. That is what the Lambda currently supports. And this is my simple hello world function. So this is by default that the serverless framework has created. I'm going to change it to I'm going to remove this These are some of the basic default data. And then I come to this. So what exactly it is expecting that we need it. This is again a default value. We do not, if we do not want, you do not need to change it. So the provider serverless framework actually works across different cloud providers. So it can work on AWS, it can work on Google Cloud, Azure as well. So that's why there are a few additional things to identify that this particular project is meant for which cloud provider. So in our case, it is for AWS, and we are using Node.js as our runtime. So we are writing JavaScript files, and that will be deployed into the Lambda as a Node.js. Then next is we need to define the function. So what this particular service is going to do is going to deploy the cloud function inside the AWS Lambda, and it will create an API gateway proxy. So it will generate a HTTP GET URL. If we hit the URL from the browser, it will actually return back with whatever code that we have written into our JavaScript function. So this is our JavaScript function code that we have written. There is no server that I have not created Express server or anything else. I have just mentioned what exactly needs to be written back. Now here I'm defining the function. So my function is very simple. Hello is my name of the function, and handler is what I have mentioned here. So handler.hello. So handler is the file name, and hello is one of the named export. So this is the hello function inside that. So it is matching with that handler.hello. That is the handler for this particular function. Now, as I mentioned, the serverless computing, whether it's an AWS, Google, or whether it's an Azure, serverless computing works based on the event-driven concept. So there has to be an event. Based on the event, the serverless compute will trigger and it will execute the code and will process and respond accordingly. So in this case, we have defined our serverless function, which we want to run, but we need to now define the event. On which event this particular function will be triggered. So I'm going to enable a simple event that is an HTTP GET event, and my URL, I want to give the URL which starts with desert hack hello. Okay, so it will create a unique URL with this at the end. So this will become the path. Method get part of HTTP. So this will respond to HTTP get. So we can actually run this from the browser. Now I'm going to, so this is ready. Now I'm going to deploy that. So serverless deploy. So this profile app gambit is related to the AWS. If you are interacting with the AWS cloud via the terminal, you need to provide the credential. In my case, I have multiple accounts, so I have created the name profiles. So in each profile, I have put the configurations, access key and secret key for that particular account. So here I'm saying that I want to deploy this into using the credentials of app gambit, and I want to deploy.
Hello. Yep. Sorry to interrupt, Dhaval sir, but I guess your presentation is invisible.
Oh. Maybe it came out of. Is it visible now? Okay. So I think some of this missed. I'll quickly repeat. So what I did is I created a new project using the serverless command line tool. So that is serverless create template. I'm going to host this onto the AWS using the Node.js. So it has generated a project. This is the framework that I'm using. It's very popular. There are basically two popular frameworks. One is a serverless, which is a commercial. Another is from the AWS itself, that is SAM, that is serverless application model. So I'm using this one. That has created a project, and the structure looks like this. It has two files, handler.js. This is a place where my serverless function is residing, and this is the configuration file. So how this will be deployed, what will be the URL, and what should happen on a particular event, that entire thing is managed from this particular YAML file. It is the structured configuration format file. So we have the JSON and we have the YAML. This one uses the YAML. Now here I have at the top, I have it has automatically, because based on the template, it has automatically taken that we are going to host this on AWS and we are going to use the Node.js as our runtime. So because we have written the JavaScript code, so this will be using the Node.js as a runtime. and we have just one function, that is hello. As I mentioned, in serverless, everything is based on event driven. You need to attach an event to a particular function so that when the event comes, that function will get executed by the Lambda. Otherwise, it will not know that what to do when. So here we have defined our function and we have given a particular event, and our event's path will be desert hack / hello. And we want this to be processed on get so that we can actually put this inside the browser URL and we can see the response. Now I'm going to deploy this. Now, usually you can do all of these things by going inside the AWS cloud as well. So this is AWS cloud. Now it looks busier. There are a lot of services. You can actually go to the Lambda service. There are no functions. I'm using the Seoul region. So that is one thing. I will copy and paste here. So I can create a function here. I can give the same thing. Function name, my runtime. There are many runtimes available, so Node.js. But this is basically a very tedious task. I need to go inside, follow the UI, and then create everything and maintain everything. So I don't want to do that. So that's why I'm using a framework which actually captures all of these things in a configuration file. And you can keep this inside the Git so that the configuration remains at one place, and you do not need to remember that whether what you did and followed to create your entire application. So that's why we are using the configuration option. Here I am assigning the function with one event, that is HTTP get. I'm going to actually execute this. So this will locally package my application and it will upload that. Now, internally, it uses a very popular AWS service, that is CloudFormation. So CloudFormation is nothing but infrastructure as a code. Nobody wants to kind of go inside the AWS Cloud UI, do everything by the click and remember, because I am building this application today. Tomorrow, someone else wants to extend it. Day after tomorrow, someone else wants to manage it. Okay. So if I'm remembering everything, that means I need to pass on these things. I need to create the documents, make sure everything is captured inside that. So instead of that, there is a concept called infrastructure as a code. In a virtualized environment, you can actually write the script which captures all the resources, configurations that you want your cloud applications to have. And finally, you run that, and your cloud provider, in our case AWS, will actually create the exact infrastructure that we want to give to our application. So here, the serverless framework internally uses the CloudFormation. Actually, it deploys everything. So we can see that what exactly it created. It created the different resources, IAM roles, the Lambda functions, API gateway, based on, because we gave that we want an HTTP event with this path and get as an HTTP method. So it will create all those things for us inside the AWS. It will create all these different resources, and finally it will say that your stack is now ready to use. So if previously there was nothing, now there was no function. If I refresh, it will say now there is a function. If I go inside that, I can see that the function code is exactly matching to the code which I wrote here. So it has deployed my function. Now I actually put a configuration that this particular function should have one event, which is HTTP, which with a path desert hack hello and method get. So it has created a trigger as well. So this is a trigger on which this function will get executed. You can see the trigger. You can see the full API gateway from here as well. You can drill it down and get there. So this is what it has appended. The dev is a stage name. It has taken from here by default. So here the default stage is dev. We can give any stage that we want. And the region here is US East 1, but we overrided the region and made it to Seoul. So this deployed everything into the Seoul region. Now this entire thing is kind of created and made available. All we did is just written a small code configuration and we deployed. Now, if I want to see whether this runs or not, I can just use this URL, run it, and now my service is up and running. Now, this is in a matter of few seconds to few minutes, you can actually create your APIs ready. Now, after that, you still need to write the code, you still need to interact with the database, but your basic infrastructure is up and running. Now, if I want to see the log, let's say this is the some kind of a log that I want to put. I made a change, I will deploy it again. It will only deploy the change part. So in this case, our function has changed, so it will deploy that function. And you can also see whether the new changes are taking effect or not. So it is update is in progress because we are redeploying the change. You can see once the update part is complete, it will show that update is completed and our code is now uploaded. Now, if I run this again, it will still do the same thing. But now I know because I put an additional kind of console log, I want to see the log part. So I can go to the CloudWatch. Now, previously, if you need to check the log, you need to go inside the server, go into the particular file, and then check the log. Here, I can just go here and see that this is my log has been written, request received. So all of these things is internally managed by the different services. Now here we are using nearly half a dozen different services internally. Okay, we are using the serverless framework, which internally uses the CloudFormation. We are using the API gateway. We are using the Lambda. We are using the CloudWatch. But as such, your code will not reflect that because all of these responsibilities are internally assigned, silently assigned. Your code is just your code. You have written only hello line, and your entire application is consist of almost 15 to 18 line of code. If you remove the white space and the comments, it is less than that. But this is your actual code. So this is what goes inside the Git and along with the configuration. But at runtime, it uses these different services together and builds the entire application. So we can check the this part. Now here you can actually also see the invocation. When someone invoked your code, so that also you can see from here that at this point in time someone invoked your function. So you have that visibility as well, that who accessed your APIs or part of your application and when, and whether it worked fine or not. So duration, for how long it worked, so 2.75 millisecond only. Success versus error, throttle, concurrent executions, if there are many more request time along with that. All those metrics is now immediately available. Because this falls into the responsibility of the AWS Lambda service, they are not giving us the visibility of the servers. So they need to give us the logs, metrics, and other ways to understand that we can actually check and make sure that our application is working as expected. So coming back to this is one simple demo. Now, second thing is not very simple. It's a very extensive example which I recently prepared. It's an online book. You can create via serverless this multi-channel board which can work from the web UI, it can work from the phone SMS, and you can actually make a phone call and invoke your bot as well. So I have written this entire open source book. If any of you want to explore more about the serverless and the serverless services, you can go through that. It's a very it's slightly big book. It's a free book. I have put a link here. When I share the presentation, you can actually go through this as well. And post this session, all the hackathon attendees, participants will receive the $20 AWS credit. So many of these things will work just fine in the $20 credit that you will receive. So those are the individual credits that you can apply to your AWS account, and you can utilize these services. So that I don't have. So I have one thing. So what we explored is just a basic thing. As I mentioned, the transition from the physical computer to the virtual machines to serverless, and why serverless is becoming popular, because it actually reduces the responsibility of the developer or the DevOps person or the operations staff, or you name it. And everyone can focus on to writing and delivering the business logic. You have these different services which are doing their own stuff. Storage services doing the storage part, authentication services doing the authentication part, compute services doing the compute part. You are just mixing those things and orchestrating your applications and focusing during the process, focusing only on what is important and not onto the server procurement or kind of understanding whether I'll be fine with 4 GB of RAM or I'll need the 8 GB, making sure that you have all the dependencies or write the software. Even the MySQL, I remember there was a time where I had to particularly spend a dedicated time to understand whether the MySQL 5.6 or 5.7 will be required. So versions also become critical in some of the cases. So we are getting away from all those things and we are only focusing on to what is required to our application. So that is one of the advantage of the fully managed or serverless infrastructure, where everything is kind of one service is doing one job at a time. These are some of the free resources which actually, these are extensive. These are multi-hour training sessions. You can again go inside, and they kind of also fast track and do the entire workshop in 2 to 3 hours. So both are very popular. This is also helps you in 3 hours or to 2 hours that building the whole application, full stack application. It's partly using the same thing that we just now saw here. It will use the S3 API gateway, Lambda, CloudWatch, DynamoDB, similar things. So that's it. I think we are to the clock, 8 o'clock. If any questions, I can answer it now. Can someone tell him it was visible the rest of the while? Is it a question?
No, it was regarding when you were not able to present your screen.
Okay. I think it was in the full screen. I lost that.
So if there are no questions, we'd conclude the session. Thank you so much, Dhaval sir, for coming. It was great to have you. And to all the participants, I would like all of you to check your mails for further sessions. And best of luck all the participating teams of Desert Hack. Have a good evening.
Thank you.